All right, thanks, Ron. Thanks for having me today. Thanks for joining, everyone. Hopefully, we'll make this a good session. So quick intro about myself. I am Jordan Thurston. I'm a senior solutions architect here at Amazon Web Services. I've been here for about 9 months now. Prior to this, I've been working in technology for 15 years, and 7 of that building specifically on Amazon Web Services, with a primary focus in modernizing legacy applications using microservices, APIs, data products, and really leaning on serverless technologies. So this topic is really right in my wheelhouse with things that I've worked in the past and seen how it can be successful. So today we're going to talk about seamlessly migrating on-premises workloads using a Strangler pattern. So let's go ahead and get started. So I think it'll be no surprise to everyone here that moving big legacy applications from on-premise to the cloud is a big task, and it can be a big challenge, and especially if you try and do it all at once. So these efforts can take really long time, whether it's just things that stretch out or you miss tiny components. It always tends to take forever. These efforts are also really big, high-risk activities. So you have to always consider all of the facets of these big legacy applications that have been around for years and years. And there's always some gotcha along the way that winds up blowing everything up. And then they also wind up being very high cost. So whether you're paying for a lot of engineering hours because the effort goes on a long time, or if the worst case scenario, something happens along the way and your application goes down, and then you start to lose revenue because your customers can't access it. So there's got to be a better way. And Martin Fowler once said, if you do a big bang rewrite, the only thing you're guaranteed of is a big bang. So let's talk about a better way to do this. The reason I quoted Martin Fowler is because he actually is the first person to first patent but use the term Strangler fig pattern. And it's actually based off of the Strangler fig plant, which plants its seed at the top of a tree and then grows its tendrils down until it reaches the soil and builds its own root system, and effectively strangling the host tree along the way. So you can apply this analogy to legacy applications where, as you migrate these monolithic apps to the cloud, you build microservices completely around that monolith. And then once you get them into the cloud, you can eventually strangle or retire that legacy application. So let's take a look at this solution we're going to talk about today. So with the Strangler fig method, or the Strangler method as it's called a lot, there's many different ways that you can apply it. And what we're going to talk about today is using an API facade. So the solution here is on the right, you can see we've got your monolithic application on your corporate data center. And we've identified 3 different microservices within that application that we want to break out. Now, there are a lot of different ways that you can analyze your applications to determine how to best split that up into the various microservices. But that is a big, deep topic. So I'll include some links at the end of my presentation if you do want to dive a little bit deeper. There's a lot of content out there, and we don't have the time to get into that. So let's assume that we have already done that analysis and decided that there are 3 core functions that we want to split up. So by using the API facade, we build this new central access point for our application so that our users and our developers now have a new point of entry to get to our application. So initially, we're just going to proxy all of that traffic through this new API gateway back to our on-prem application. So this is big picture. We'll dig in a little bit deeper about how all these different components work. So the 3 core components of this solution are the on-premise connectivity. So how are we going to take our on-prem application and connect it to the cloud? So by doing that, in this solution, we're going to use AWS's Direct Connect service, which provides a dedicated connection between your on-premise service and AWS. So this is a hardware solution that gets installed in your data center and builds a secure connection where you can route traffic from your on-prem and directly to AWS. So this is where you really start to get into that hybrid environment, and this allows you to run in parallel on-prem and in the cloud. So the next part of the solution is the API facade itself. So we're going to leverage Amazon's API gateway for this. And this is going to create that one entry point so that all of your applications, your developers, your users that are interacting with your application are going to connect now to this API gateway. And that's going to enable a lot of different things. One of which it's going to allow you to continue to use this single entry point for your legacy application on-prem, as well as reroute the traffic to the new microservices as you break them out and migrate them. And that'll give you a great user experience for your customers, great user experience for your developers, as well as allow you to have a new central location for things like security, logging, monitoring. All of that is still going to get funneled in through one entry point, regardless of whether it's going to your on-premise data center or whether it's going to your new microservices as you move those into the cloud. And it also allows you to add different control mechanisms there, like throttling and usage plans. So again, just better utilize how your application is being accessed. And then the third key component is really the bulk of this, and that's the microservices themselves. And in this example, we're going to use AWS Lambda, which is AWS's serverless event-driven compute service that lets you run code without any backend. Now, there are a lot of different options with AWS for how you can run microservices. You can do it on Lambda, like we're going to talk about today. You can do it on our EC2 service, which is our Elastic Cloud Compute, which is basically like a virtual machine in the cloud. Or you could use containers, which my colleague Ryan is going to talk about containers a little bit after me. But I, several years ago, was a system administrator, and now the last thing that I want to do is think about managing servers. So I always lean towards AWS Lambda, which is that serverless application. All right, so how are we going to tie all of these together? So let's look back at our architecture that we showed before. So on the right, we've got our data center, and now you can see the AWS Direct Connect right here. This is that service that's going to connect your data center to the cloud. So now within the cloud, we're going to jump over to the left here, and we've got our user talking to our API gateway. And this is that API facade that we're talking about. So any call that this user or application is going to make, it's going to start with that API gateway, and then we're going to route the traffic from there. So initially, it's going to proxy everything because, as we can see on the right, all of our application is still on-prem. But the way that we're going to connect these together is going to get a little more complex than just a one-to-one. As you can see, there is a lot more going on in the middle of this diagram here. So to make sure that this is a secure and redundant and resilient connection, we're going to connect the API gateway using a VPC link. So with AWS, a VPC is a virtual private cloud. So this is your own private, secure, segregated piece of AWS within your account that allows you to control all of the access and then the workloads within that environment. And within there, you also see the two different availability zones. Availability zone is one or more closely located data center. So in this solution, we're going to take the traffic coming from the API gateway, route it to this VPC link, and then we're actually going to spread it across a network load balancer, which will balance that traffic across two availability zones. So this will help with that resiliency. So if for some reason availability zone were to go down, that network load balancer would then route the traffic through the other availability zone. And then all of it is going to end up on that direct connect within your corporate data center. So this is the overall architecture for the API facade that adds that central gateway for everything that we're going to be talking about today. And now this is just that facade. So next, we can actually start strangling the monolith. So what we're going to do here is we've got all of our application on the back end, and we've identified these three different microservices for things that we want to move out. So the first thing that we're going to do is we're going to take the function that we've identified as function A, and we're going to package this up as a Lambda. And again, I said Lambda is serverless code. So you basically develop a wrapper around that code within So take that code out of your monolithic application, develop an event-driven wrapper so it can be triggered by things like API gateway. You can set up event bus jobs that can trigger it, or any number of AWS service can trigger a Lambda. So by taking this code out of your legacy application, building this wrapper around it, you can then deploy it in AWS as a Lambda, which is essentially your microservice. So now that it's up there, right now in this example, the traffic is still being routed to our monolith back on-prem. So what we're going to want to do now is go ahead and create a new resource within the API gateway that says any call that comes to this API gateway that is looking for function A, it's going to route the traffic there directly to that Lambda function. The function is going to run in its isolated environment, do whatever it needs to do, and then send back the API response back to your user or your other applications. So we've now effectively taken a single piece of that monolith, pulled it out, put it in AWS. And now we can go ahead and retire that chunk of code. So this is where we start to really strangle that monolith and really reduce the size of that application. So we're reducing the code base, so it's less to maintain on-premise. And we're also reducing the blast radius of that function A. So now that this is a standalone microservice, you can develop code and release development cycles on a much shorter period because there's such a smaller code base and less redundancy or less reliance on other code. And this also means that if you're deploying code on function A, there's less risk of it taking down functions B and C because it is in this isolated environment. So with that pattern, that's really the key to it right there is identify a microservice, extract the code, repackage it as a microservice or a Lambda, and then deploy it to AWS. And then you can retire what's on-prem. So again, we'll do the same thing with function B, create a new resource in that API gateway, start routing traffic there, and then go ahead and retire the function on-prem. And as Ron said earlier, a lot of things are living in this hybrid zone these days as companies are just continuing and just starting their cloud journey. So with this pattern here, let's say in this scenario, function C turns out to be a lot more complex than we initially thought. So we want to leave that one on-prem, at least for the near term. With this pattern, your developers and your customers are still going to be able to access function C on-prem while also leveraging all of the benefits of cloud with functions A and functions B. And this is just one example of how to use the Strangler method, but it's a great path to slowly migrate at your own pace and get things to the cloud and leverage all the benefits of the cloud without having to do that big bang migration. And a lot of these topics, I've stayed very much at the high level just because this is such a fast, rapid session. So I've included a lot of links in the additional resources of this presentation. And I'm also going to include my email on this presentation as well. So if any of you have any follow-up questions or want to dive deeper into any of the topics that I touched on today, please reach out. I'm very passionate about migrating to the cloud and really leveraging microservices and things like that. So I would love to chat about it. But that is all I have for today.